I'm excited to be moderating today's webinar. Our guest with us is Lindsay Fernandez-Salvador. She holds a Bachelor's of Science from Oregon State University in Natural Resource Management and a Master's from University of Florida in Geography. She has over 10 years of work experience on both conventional and organic farms in Oregon, and her graduate research thesis examines market conditions that contribute to small organic farm success. Through this research, she became familiar with organic standards and issues facing organic farmers. Prior to attending graduate school, she worked as a forest technician and GIS technician. She has lived and worked in Latin America and is fluent in Spanish and has been with OMRI since 2009. And she's here today to discuss inputs in organic systems, and this is a topic that Ben and I respond to quite regularly from folks at NRCS when they're working with organic farmers, questions, concerns, and just clarity and idea of what some of the more common products are that are used in organic systems. So I'm happy to turn it over to Lindsay to talk more about that.
Thank you, Sarah. Okay. All right, so today, like Sarah said, we are going to go over common inputs used in organic production. And I'm also going to sprinkle in there a little bit of up-and-coming technologies that are going to be used, in my mind, a little bit more so that you can get ahead of what's coming. There is my contact information. As part of my work at OMRI, I receive technical questions from the public, and there I am. I'm very happy to find my big fat worm in my compost bin there. For those of you who are not familiar with OMRI, we are a nonprofit organization, and our mission is to support the growth and trust of the global organic community through expert, independent, and transparent verification of input materials and through education and technical assistance, such as this webinar. Today, what I would like to go over is the basic regulations around inputs for use in organic production. And then we're going to look at fertilizers, soil amendments, and pesticides. Obviously, there's inputs for use in livestock production as well, but given the fact that most of us work on farms and with crop producers, we're going to focus on the fertilizers and soil amendments and pesticides. We're going to have a chance to look at labels and do some interpretation of those labels based on what we've learned here and when we should be going back for more information or asking somebody that has more technical knowledge. And then I'm going to talk a little bit about using the OMRI list, both for NRCS professionals and for talking to farmers about using the list. It's good to know the basic information about how OMRI structure is set up. So getting into the basic regulations, the overarching requirements for organic crop production for inputs is that natural substances are permitted. And there are a few exceptions, mainly sodium nitrate is restricted, as well as tobacco dust is prohibited, and calcium chloride is restricted. Now, the regulations call natural substances non-synthetic substances. So the word natural and non-synthetic are synonymous in our case. On the other hand, synthetic substances are in general prohibited, and there is a list of exceptions that are called the national list. And so if you hear somebody referring to the national list, that's what they're referring to. And it's about 20 to 30 substances, sometimes large categories, sometimes singular substances. And this is where we derive most of the micronutrients and inert ingredients that are used in pesticides, for example. So what is the definition of synthetic and non-synthetic? The regulations contain a definition, and it for non-synthetic, and that is a substance that is formulated or manufactured by a chemical process or by a process that chemically changes a substance extracted from naturally occurring plant, animal, or mineral sources, except that such terms shall not apply to substances created by naturally occurring biological processes. So I want to break down this definition a little bit here. The first part is a substance that is formulated or manufactured by a chemical process. Here, that is something very clearly synthetic to most people. This is an intuitive thought, right? So urea would be a classic example where urea is formulated by a chemical process, right? It starts with two different chemical substances, and those chemical substances react together to form urea. That is a classic synthetic substance. But the second part here about being formulated by a process that chemically changes a substance when it's being extracted from naturally occurring plants. So what they're referring to there is when a substance such as rosemary oil is being extracted from the rosemary leaf. And when it is extracted is if there is some chemical change that's being made during that extraction process, that's where it might be synthetic. Most extracts, however, from botanical substances, for example, are non-synthetic because they don't chemically change during that extraction process. And then finally, this last part here, that this is an exception, that such term, being synthetic, shall not apply to substances created by naturally occurring biological processes. So that came about when people said, well, there are chemical changes going on at all times during the composting process. And so what the rule makers wanted to make sure to do was to exempt those types of processes like fermentation, like composting, and other minor things like enzymatic hydrolysis, for example. So it can be a quite complex process to determine if something is synthetic or non-synthetic, and this would be an area where if you were unsure, you could contact OMRI or a certifier that you were working with. The section that deals with allowed synthetics is Section 205-601, and this is the area where all sorts of synthetics are covered. So in the pictures here, we have examples of what can be used as a mulch, for example, like the cardboard there. Yes, paper is considered synthetic. We have algicides available, large animal repellents, miticides, micronutrients, compost feedstocks, and slug repellents and killers. So there's more than this, but this is a good sampling of what we've got on there. And then 205-602 is the section with prohibited non-synthetic substances or natural substances. I want to focus just slightly on Chilean nitrate or sodium nitrate. This is a really confusing substance right now. You might have heard from some of your clients that they're confused about whether or not they can use sodium nitrate right now. And I don't have time to go into all the details, but I wanted to say that right now sodium nitrate is allowed for use. The farmer must use it with thoughts and procedures toward maintaining the ecosystem and biological aspects of the soil. So, in other words, using it judiciously. And if you have clients that need further information or are confused, I welcome questions around that because it is rather confusing right now. Some of the basic pesticide regulations include the fact that the active ingredient of the pesticide must be either non-synthetic, such as a microbe or a plant extract, or it must be a synthetic material on the national list at 205-601. And then any inert ingredients that are in the pesticide must be from a 2004 EPA List 4, or they must be non-synthetic. So the entire formula for pesticides must be evaluated. The challenge with pesticides specifically is that most of them only list the active ingredient on the label, and the inert ingredients are proprietary information to the manufacturer and to the EPA. So therefore, most farmers will be unable to determine if a pesticide is compliant just by looking at the label. They will have to ask their certifier or OMRI to get that information. 205-203 is the section that deals with soil fertility and crop nutrient management. This is a pretty meaty section in terms of inputs, and it covers a number of very important restrictions. So, for example, this section prohibits the use of plant and animal materials that have been chemically altered by the manufacturing process. So this is just reiterating the fact that synthetic substances, even those that were originally derived from plant and animal materials, are prohibited. This section establishes the compost production parameters, and it establishes the days to harvest rule. This is the restrictions around how many days after a manure application can you harvest a crop. And then this section also allows for ash from plant and animal materials as long as it's not combined with prohibited substances. So again, that's reiterating the fact that inputs need to be comprised completely of allowed materials. Okay, getting into fertilizer, soil amendments, and pesticides. Now that we've gone through the basic regulations, let's dive a little deeper into some of these common inputs. For the purposes of on-farm feedstocks, you're likely going to see the majority of just the crop residues and things like that. But when a farmer is purchasing an off-farm compost, they need to make sure that the feedstocks are compliant for organic production. So those feedstocks include plant and animal materials that are, as long as they haven't been chemically altered in some way. It includes mined minerals, things like inoculants that might catalyze the composting process, and paper and cardboard, which are considered synthetic but are both on the national list as compost feedstocks. One of the major issues that is coming out of municipalities especially is the fact that they are permitting the use of compostable plastics. So here in this picture, many of us know that we go out to our own yard waste bins and we put our food scraps in there, and then that's taken to the compost. And many municipalities, in order to encourage that sort of activity by the community members, they will actually give you free compostable bags and things like that. And they are accepting compostable plastics in their waste stream in general. So compostable plastics are not permitted as a feedstock in compost for organic production. This has been confirmed by the National Organic Program. So therefore, that is something that the farmer should be aware of and try to make sure to avoid in the future. The regulation also contains compost methods, and it stipulates two different types of compost methods. The first one is a compost made in in-vessel or static aerated piles. An in-vessel is kind of what you would picture it to be. It's a enclosed container, and a static aerated pile is where it's put into a pile, and usually they pump air through pipes. The C to N ratio, the carbon to nitrogen ratio, is stipulated to be between 25:1 and 40:1. And the temperature must be maintained for 3 days between 131 and 170 degrees Fahrenheit. With a windrow compost, the C to N ratio is the same, but the temperature has to be maintained for 15 days between those same temperature ranges, and it must be turned for more than 5 times during that same time period. So if you were talking to a farmer that had an on-farm compost, they would need to be meeting these stipulations. And in fact, especially if they're using manure as a feedstock, would need to be providing logs and records to their certification agency to ensure that they were meeting these stipulations. So let's talk about the restrictions around compost, because not all composts are created equally and not all records are required for compost. So when a farmer makes, or an off-farm municipality makes compost to the specifications in Section 205, 203, that compost can be made or can be used without restriction. So even if it has manure as a feedstock, as long as it's made to those specifications, it can be used without any restriction to its days to harvest rule. Anything that is uncomposted or partially composted and is a plant material only, in other words, it has no manure in it, that also has no restriction to the days of harvest. Now, this is a clarification that's important to a lot of farmers, especially in California, because they have some pretty serious leafy green regulations. And one of the concerns with uncomposted or partially composted materials is that the risk for pathogens is higher. So because of that, OMRI places the raw manure or the days to harvest restriction if the pathogen levels exceed 1,000 mpn for fecal coliform or 3 mpn for salmonella. And that is a standard that is also taken by the EPA for Category A composts. So if you are dealing with an uncomposted material, just residues or partially composted plant materials, they can be used without restriction, as I stated earlier, but there is that risk of elevated pathogen content. And especially when you are getting it from municipal green waste sources, there is a risk for pesticide residues. The composting process for most pesticides does break it down, but when it's partially composted, it can be at a greater risk for pesticide residue. Some of the issues with mulches and paper that one should consider is that there is a prohibition on glossy or colored paper. So we're talking about magazines, for example. But newspapers, on the other hand, are permitted as long as they're recycled. So some of the issues that might come up is waxed boxes. So now farmers may be using waxed boxes to store and transport their produce, and some of them, the boxes might get out of shape, and so eventually they might look to do something with them. OMRI has taken the position that those wax boxes are prohibited because they're considered to have a glossy coating, which is not permitted. And the other concern is fumigated boxes, especially those that are coming from conventional tropical shipments. And otherwise, ingredients should be natural or synthetic on the national list for that particular cardboard paper. Now, this is one of the substances, the biodegradable plastic mulches, that is currently not permitted for organic production. However, it is undergoing rulemaking and has been recommended by the National Organic Standards Board to be permitted. So it is coming down the pipe, and I know that a lot of farmers are really interested in this technology. And what it is, basically, it's very similar to compostable plastics, but instead it is a black plastic mulch, typically black anyway, and it actually breaks down over time and is consumed by the soil microbes. And so if your farmer or your client is interested in this technology, the basic thing to know here is that the rulemaking is happening and eventually it will be permitted, but there are some pretty significant technical specifications around which ones can be used, and so to make sure before using them to check with their certifier or see that it's OMRI listed. I wanted to go over a classic example of a very common soil amendment, lime. And this is a great case where something can be made both synthetically and as a non-synthetic substance. And depending on which one you use, it can potentially be an application of a prohibited substance. Now, in the left bottom hand picture, limestone is depicted as a mined mineral here. So calcium carbonate is the chemical name for limestone. In the top right-hand corner, we have a depiction of limestone that's also considered to be sugar beet lime or sugar lime, but chemically speaking, it's also calcium carbonate. So both of these, chemically speaking, are identical, but only the limestone that is mined is permitted, whereas the limestone coming from the sugar beet processing is prohibited because it is synthetic. Now, I just want to go quickly and show this as an example of what is synthetic. What happens is beets get cut up and they get soaked in some water, and they mix in calcium hydroxide into that water and that sugar beet juice, and that what happens is that it starts to react with some of the particulates and takes out some of the impurities in that sugar beet liquid. And then to remove that calcium hydroxide, they pump in carbon dioxide, and the carbon dioxide reacts with the calcium hydroxide, becomes a solid, and comes out of solution with all those particulates that were in the juice. And that reaction is calcium carbonate and is used very regularly as a conventional liming agent. Biochar is another hot item that a lot of farmers are interested in experimenting with. Biochar is typically made from some sort of hardwood or other waste plant material, and what it is it is burned in the absence of air, and it creates, that's called pyrolysis, and it creates the substance here that's at the top right hand corner, where the pores are enlarged and they give the plant material certain benefits that ash doesn't have, for example. This biochar is currently permitted as a non-synthetic substance, and some of the concerns around this substance is mainly during the pyrolysis process that any of the feedstocks might have had synthetic substances added to it, or the pyrolysis process itself had synthetic substances added to it, and so therefore it wouldn't be permitted. So the two things mainly to look for here is that the feedstocks weren't treated with anything, and then the process itself didn't have any synthetic processing aids. So the top 5 animal ingredients that you will see in organic production is bone meal, blood meal, feather meal, fish meal, and bone and meat meal. Now, this doesn't include manure, obviously, because that's a category all of its own. But these are the typical commodities that you'll see. Bone meal and blood meal are both extremely expensive, and as is feather meal, but they all provide wonderful nitrogen, as well as fish meal. One of the main concerns with fish meal is that it's coming from Mexico, and so therefore there are some shipping issues, and so they might be putting preservatives into it that aren't permitted. Manure-based products are a little more complicated. They have restrictions about when they can be used and how. When manure is used as a feedstock in compost, the restrictions on the days to harvest rule depend on whether that compost was made to the specifications in 205-203. Just straight manure application to the crop has a restriction for the days to harvest from 90 days when it doesn't come into contact with soil particles. So, for example, if you applied it to as a dressing to an apple tree, it would be a 90-day harvest period to when you could harvest the apples. On the other hand, if it was a lettuce application, and so you applied the dressing to the lettuce, and then you couldn't harvest the lettuce after 120 days from the application period. The same would be true if you made a manure tea, for example, and then did a foliar application. That would be like a direct contact with soil, and so a 120-day period would be needed. On the other hand, there is a class of manures, they're called processed manures, where they can be used without any sort of days to harvest rule restriction. These must be heated to at least 65 degrees Celsius for an hour, and the moisture level has to come down to 12% or less, or any other equivalent heating and drying method, as long as it meets pathogen thresholds that I mentioned earlier. Another interesting technology, especially this is coming out, especially on dairy farms so that they can process their manure better, is anaerobic digestion. And this is becoming more interesting as well to food waste processors. And what happens there is that we've got two outputs from the anaerobic digestion process. We've got this solid digestate that's depicted there in a picture, and then there is a fluid digestate. Now, depending on whether or not this process undergoes some sort of heating and pathogen reduction, it may possibly be used without restriction if it contains manure as a feedstock. Otherwise, plant-only feedstocks can also be used without restriction, as long as the pathogens are low. And these anaerobic digestates are up and coming most definitely as a compost feedstock and fertilizer. So this might be something that's interesting to you. And I would imagine even at our NRCS you also have to advise on managing manure, and so this would be one of those ways that farmers would do that. Fish products are also a very common input used in organic production because they have such a high nitrogen level. Fish products in general are permitted, both liquid and dry fish meal is permitted. And when it is liquid, it is permitted specifically to contain phosphoric acid, being the most common stabilizer, but also may use sulfuric and citric acids. They can only use the phosphoric acid down to 3.5 pH. This stabilizes the fish so that it doesn't over-ferment. And the reason that this has to happen is because fish contain high amounts of fats and oils, and this causes rancidity, and therefore ethoxyquin is the most common preservative used. It's not permitted in fish products for organic production, so it should be looked for on the MSDS or the label. And typically these types of products are made from rendered fish parts, so bones, guts, heads, that sort of thing. And almost all liquid fish fertilizers at OMRI are stabilized with some acid component. So one of the things that farmers may consider about using fish fertilizers that have been stabilized over time is that it can contribute to a decrease in soil pH. And fish fertilizers, especially liquid fish fertilizers, are popular and growing more in popularity because of the fertigation system that a lot of farmers employ. They can be pumped through the irrigation system. They're relatively soluble in water, and while they could plug emitters, they are a good option for fertigation systems. The other thing that anybody that advises farmers for organic production should be aware of is that inputs, fertilizers specifically, that have high nitrogen and they are liquid must undergo 2 inspections per year by an organization such as OMRI. I believe in the United States, OMRI is the only organization that performs these inspections, and every certificate that is issued to these manufacturers of these high nitrogen liquid fertilizers has to have a statement on that certificate that says this has been inspected by an organization. And anytime a label has a greater than 3% nitrogen analysis, this is where the eligibility takes place for types of products. So you're looking at both a liquid form and the greater than 3% nitrogen. Okay, getting into some common pesticides. There's many different types of pesticides in organic production, but we're just going to focus on a couple of the ones that are pretty common. One of them is spinosad. That is a fermentation product. Pyrethrum is a plant extract. Bacillus thuringiensis is a microbe. And then farmers can use soaps and sulfurs as well. So these are some of the most common pesticides that you would find. Okay, we have time for questions. And I understand that the moderator is going to read them to me.
Yes, Lindsay, thank you. Before I read through some of these, I just wanted to remind everyone that these slides, the entire PowerPoint is available online at conservationwebinars.net. So if folks are trying to get everything down in notes, you're welcome to visit the website to check those out. So I have a couple questions for you. I frequently get asked about the animal byproducts that are used as fertilizers in organic systems and whether those sourced from non-organic farms. And currently, that I know is fine. Have you been a part of any conversations where that could change, or do you have any other insight into the issues that can arise when they're being sourced from non-organic operations?
Yeah, that's a good question. To my knowledge, there's no talk of changing the current permitted byproducts from non-organic farms. So right now, non-organic animal byproducts, including meat renderings, bones, and things like that, those are all permitted from non-organic farms, and including manure as well. While there has always been conversation amongst industry members that manure is often contaminated with all sorts of drugs and antibiotics, there hasn't been any real significant movement towards otherwise prohibiting that practice.
Okay. There was also a question about pesticide residues in compost and how closely that's assessed. Things growers can watch out for, what certifiers are looking for in relation to that?
Yeah, currently there are not established parameters for pesticide residues in compost. A couple of years ago there was a bit of controversy around a particular bifenthrin, which is an insecticide. And what the NOP, the National Organic Program, did in response to that particular issue is that they put out a guidance document stating that, or what I should say, reiterating that compost made from green waste and other feedstocks that may be contaminated with pesticides are permitted as long as the farmer does their due diligence for managing for that possible contamination. So a farmer that's using compost might look for die-off in some of their crops. They might be wary of certain compost feedstocks if you're a municipality, for example, that is surrounded by golf courses. That could be a possible issue. Or similarly, crop residues that are known for having high pesticides. Depending on where you are in the country, one of those could be cotton, for example. So it's also sort of monitoring where your own municipal compost comes from and what's feeding into that. Those are the two biggest things that I would look for if I were out there.
Great, thanks. And I just have two more, I think, relatively quick questions. How do you analyze the carbon to nitrogen ratio or figure out whether it meets the rule for compost feedstock?
Well, at OMRI, we require a laboratory test. It's a carbon combust test. I don't know what exactly it's called. I'm not involved in that exactly. But as a farmer, there's actually several resources out there. There's one called the Clickatat, and I can provide this link to Sarah later on. Maybe she can forward it. But it's actually a carbon to nitrogen feedstock ratio calculator. And so you can input all these different types of feedstocks and how much you put into the compost, and that'll give you a relatively good ratio of carbon to nitrogen. I don't think that certifiers do particularly in-depth analysis of the carbon to nitrogen ratio, and that's because the NOP has put out guidance documents that there's other ways of determining that compost is compliant, like looking at the mixing and the managing the compost and whether or not there's any pathogens in there left over. So I think sort of guesstimating based on some good resources that there are available is sufficient for most farmers.
Okay, and lastly, there's a couple questions here about mined materials. So what would be an example of a mined material used in compost? And a question wondering whether mined potash is allowed.
Okay, what would be a mined material? I think the very most common one wouldn't necessarily be used as a feedstock in compost, but it's blended with compost, and then it's like a custom blend would be gypsum. That would be the most common that I know of. And then, I'm sorry, what was the second question, Sarah?
Whether mined potash is allowed.
Oh, yes, mined potash is permitted, yes.
Okay, great. Well, I think with that, I'll let you continue on, and there's a couple more questions we can save for the end.
Okay, fantastic. Okay, so we're going to do a little bit of label interpretation here. Some of the labeling concerns that you might come across and that OMRI often comes across as well is the ingredient statement versus the derived from, quote-unquote, statement. And we're going to talk about the difference between those two. The higher than expected nutrient values, because there is no federal oversight of fertilizers for use in organic production. There are some companies that might be claiming higher than expected or have ingredients in there that are otherwise not permitted that contribute to this, and thinking through those red flags. And then false or unverified compliance claims or the misuse of the word organic on fertilizers and pesticides. So, looking at the derived from statement versus the ingredient statement. The derived from statement is different than an ingredient statement in the sense that all of the substances that are listed after derived from are those where the guaranteed analysis comes from. So in this particular label, the ferrous sulfate and magnesium sulfate, etc., those are all where the micronutrients are coming from. That doesn't mean that this product only contains those ingredients. On the other hand, if you saw something that said ingredients and then listed out all the different ingredients, that is far more likely to have a complete list of ingredients than this derived from statement. So the thing to note here is both examples, you can't always know by the label if something is compliant for organic production, but the derived from statement is much less likely to have a complete list of ingredients, and so therefore the farmer should talk with their certifier first before using the substance. And then I wanted to point out this interesting thing called complexed with lignin sulfonate, which might throw a lot of people off. Micronutrients typically need to be chelated, and complexed and chelated is really interchangeable in this case. And lignin sulfonate is one of those synthetic substances that can be used as a chelator. I wanted to look at a product, X, that I found it on the marketplace, and it has some serious red flags. So if you were consulting with a farmer and he was telling you that he wanted to use this product, there would be a couple of red flags that I would bring up. So, for example, it has a pretty high phosphorus content. And so the question might be, is it stabilized with phosphoric acid? And if it is, to achieve that high of a phosphorus level, they would likely be needing to use more phosphoric acid than what is permitted in the regulations. And the fact that it is a liquid product and it is greater than 3% nitrogen means that this product must be inspected twice a year by either OMRI or another certification body. And then down in the contents, you can see that it contains fish solubles and feather meal. So as somebody who's familiar with feather meal, it is not very soluble in water, and so in order to be liquid, the feather meal needs to be hydrolyzed pretty seriously first. And so asking what's that, the hydrolyzing agent, or what's that synthetic processing aid could be a question. And then down here, the micronutrients are derived from seaweed extracts, borax, and complex sugars. So unfortunately, when a substance contains micronutrients, you both need, as a farmer, you need to show that you have a deficiency in soil when you use a product that contains a synthetic micronutrient. And they also need to know how much of that micronutrient is in the label. So that statement, for example, for complying with organic regulations is too vague. Okay, getting into false or misleading label claims. One of the greatest things, and this is one of the reasons that OMRI was formed, was because it's hard to know whether or not fertilizers and soil amendments and pesticides are in fact compliant with organic standards. So I just did a quick Google search on organic fertilizers, and I came up with this really long list. Now, some of these may be completely compliant, and some of them may be OMRI listed, and some of them may not be compliant. But because of the fact that there are no federal oversight regulations, it can be confusing to the farmer to know what is and is not compliant. The milorganite on the left side is particularly confusing and misleading because it says it's organic nitrogen, and it's even got this organite in the name. And this particular substance contains sewage sludge, which is completely prohibited in organic production. So this is where OMRI works pretty hard to make sure that all of the label claims that our clients are making are true. Okay, let's get into using the OMRI list. Okay, so we have two lists. We have the OMRI products list. A lot of people think about them in terms of color coding. So our blue book is the brand name products list, and our green book, sorry, I switched those around. I'm sorry, the green book is the OMRI products list, and the blue book is the generic materials list. And here I have a picture of a generic material. This is a book that OMRI created to basically classify all these different materials that are used in organic production and under what kinds of conditions they can be used and how they can be made and where's the rule, where we derived it from. So in this example, I'm going to go clockwise here, starting with category. You can see that that is the material entry that corresponds to the main ingredient or the product function, so compost tea in this case. It's also called a listing. And then underneath you have a class, and we have divided products and materials into 12 different use types. So in this case, in crop production only, we have crop fertilizers and soil amendments, crop pest products, and crop tools and management aids. And then we give the citation. This is if you are really a policy wonk and you want to understand it from the source, you can go back to that citation and see where we derive the compliance and annotation. The use annotation and descriptor, this is the area that describes the restriction or any other OMRI standards that we might have for that particular listing. The classification describes whether a substance is synthetic or non-synthetic. Sometimes it can be both, and so it will say both non-synthetic and synthetic. And then the status attributes that describes compliance. So it could be either allowed or allowed with restrictions depending on the substance and whether it has an annotation in the regulation. And then tying the generic materials list to the products list is a matter of taking the generic restriction for, say, copper sulfate and then searching for a copper sulfate brand name product on our list. So here we're talking about any copper sulfate. On the right-hand side, we're talking about Triangle brand copper sulfate crystal. And that particular brand name has the restriction for copper sulfate. Now, this serves two purposes. It allows OMRI to categorize products for the end user. So the end user can say, I need a copper sulfate, and they look for that. And then it also allows us to track changes in regulations through time so that, say, copper sulfate and the allowance for copper sulfate changes in the future, we will be able to contact Triangle brand and tell them, the regulations have changed, and so therefore we need to update your product, or we need new information or whatever. So that basically happens at any time when the regulations changes, and that ensures that our list remains with integrity and completely up to date. And you can go onto our website and search the different OMRI lists. So on the right-hand side there you see the little box, the search box, and there's a products tab and a materials tab. You would search for if you were looking for spinosad, for example, but you wanted the products, you could type in spinosad there, and it would pop out all the products that have been listed under the spinosad category. Or if you just wanted conserve natural light insect control, then you could search for that as well. You can even search for NPK profiles, which a lot of products contain the NPK profiles in their name. So if you were looking for a 311 or a 521, you could even do that type of search. Or finally, if you liked a company in a certain way, you like their suite of products, you could search for that company in general. Okay, that concludes my presentation, and I think there's time for more questions.
Great. Thank you so much, Lindsay. One of the questions that came in, I think might be pretty straightforward, is what some of the options are for phosphorus in organic systems beyond manure.
The options for phosphorus beyond manure is guano. One of that, and guano is kind of like a manure. Phosphate rock is, and rock phosphate is one of them. There's not a lot of options. Those are the three main options that you have. There are no synthetic phosphates available for use as a fertilizer.
Great. Thank you. And another question was regarding the proposed food safety rules, and I was wondering if maybe you could briefly mention, I don't know if OMRI responded to those or provided comment, but how this proposed food safety rules would impact how organic producers could use amendments, if at all.
Yeah. OMRI did not provide comments specifically on the food safety rules because we're members of the Organic Trade Association. They were pretty heavily involved, and their particular comments really covered OMRI's concerns. And it was mainly around the days to harvest rule when using manure and or a compost. And to my knowledge, the FDA heard those comments specifically, and there was a positive outcome where they were restricting it more when you used manure. They were even restricting it that you had to apply the manure even much further away than that 90 to 120 days, which was a concern for a lot of organic farmers. To my knowledge, I know that the FDA hasn't completed that rulemaking, but I think that was a positive outcome and that they did make some concessions for especially organic farmers in that area.
Great. All right. I'll give folks one last chance to write in if they have any last questions. Do you, I know OMRI only really reviews materials, but are there any resources that you would suggest if people wanted to learn more about what their options are?
For inputs?
Yeah, I mean, if someone's, they got their soil test back and they know they need to apply a certain amount of nutrients, are there resources that you generally direct folks to get that information?
OMRI doesn't have a comprehensive thing for that. No, we don't. We usually go back to looking for that NPK profile or looking for specific substances in the product list.
Okay.
Because they're actually not allowed to consult in that way, and certifiers are also not allowed to consult in that way, just because of our accreditation purposes. So, yeah, but a number of organic farm associations, in various states, they have their farm associations. That's the kind of work that they do.
eOrganic and ATRA both provide information nationally to farmers, and I know they have quite a bit of information on their website, so that might be a good resource for folks. Yeah. And it looks like there are no more questions coming in, so with that, I think we've concluded today's webinar. I want to thank you again for joining us and remind folks that these materials will be available at conservationwebinars.net, and hopefully folks will tune in for our next webinar on lean management here in a couple months. So thank you, Lindsay.
Thank you.